Microsoft's new Majorana 1 processor is the first quantum chip powered by a topological core, based on a new class of materials that could revolutionize the way we approach complex problems. Microsoft made this announcement in the field of quantum computing, unveiling a new quantum processor that is prone to less errors in computing. Before we dive further, let's get to know what quantum physics or quantum computing is. Quantum physics is a branch of physics that studies the behavior of matter and energy at an atomic and subatomic level. At this scales, the classical laws of physics no longer apply, and strange, seemingly random phenomena govern the behavior of particles. Quantum computing, on the other hand, harnesses these phenomena to perform calculations that are beyond the capabilities of classical computers. Microsoft's Majorana 1 is a quantum processor that uses a novel state of matter called topological superconductivity to store and manipulate quantum information. This approach relies on the creation of Majorana particles, which are exotic particles that can exist in multiple places at the same time. By harnessing these particles, Microsoft's Majorana 1 processor can perform calculations that are more stable and less prone to errors than other quantum computing approaches. This breakthrough promises to usher a new era of computing, enabling the creation of a truly meaningful quantum computer in years rather than decades. Microsoft's approach differs from others in the industry, focusing on developing new quantum technologies designed to be more accurate and less prone to errors. The Majorana 1 processor features 8 topological qubits, which are inherently resistant to errors. Microsoft plans to scale up to 1 million qubits, which could lead to innovations in fields like sustainable energy, healthcare, and material science. In an interview, Chetan Nayak, Microsoft's technical fellow and corporate vice president of quantum hardware, described the innovation as the transistor for the quantum age. He described the company's 19-year quantum computing initiative as a moment we've been dreaming about for a long time. He also emphasized that Microsoft's approach is focused on developing new quantum technologies that are more accurate and less prone to errors.
The underlying qubits are based on these kinds of collective excitations of these very special systems, which are called topological phases of matter, which have this property that they have these excitations that are like particles, and when you exchange them, the quantum mechanical wave function changes. But another way of saying that in a more computer sciencey sort of way is saying, hey, I do some operation and it does a quantum gate on some underlying quantum information. And the other thing that we are fairly certain the quantum computer will be useful for is simulating quantum mechanics, right? That was Feynman's original when he first thought of quantum computing. That was the application that Feynman had in mind, and because of the richness of quantum mechanics, because of superposition and entanglement. The description of a system in quantum mechanics is in terms of what's called the Hilbert space. And Hilbert space is extremely vast and therefore very difficult to simulate.
Microsoft's breakthrough has been met with excitement from industry analysts, with analysts stating that it fundamentally changes the competitive landscape.
So complicated that then if the classical computer was as big as this entire planet, it would still not be able to compute it, just to give you a construct of scale. And a quantum computer can do it, and can do it very, very well.
At the core of a quantum computer are these qubits. Qubits are like our classical bits, right? These are essentially zeros and ones in a transistor. And we need the analog of that in quantum computing. The analog is a qubit, a quantum bit, that serves as that core information unit. It's where we store the information and then we process on those qubits to create computation and ultimately, get solutions back out.
The challenge is qubits are actually pretty delicate in general, so you need underlying qubits that are really stable. But you don't want that to come at a cost. because you don't want your underlying qubits to be really big. That's one way to make them more stable, is have them really big. But if they're really big and you're still going to need many of them, then how are you going to fit them all into your system? You don't want to deal with something the size of a warehouse. Then the second thing is you don't want the qubits end up being slow, right? Because if the price you pay for getting something stable is you have to go really slowly, then a computation that might take you a month ends up taking you a decade, and then it's not useful. People in the early days of computation used vacuum tubes, and then that technology, actually you could build very good computers with it, and then the transistor was invented, and the earliest transistors weren't necessarily that great, but it became clearer over time as the transistor developed and the integrated circuit developed that this was going to be the technology of the future. In that spirit, that the first generation of qubits may not be what gets us to the next stage where we can really solve the kind of problems I was mentioning that are really important. And so we might need to invent a material and therefore a quantum processing unit that has the right properties. So for us, we want something that has some built-in level of error protection. And a lot of those ideas actually were explored in the context of software, of quantum error correcting codes, but you can actually build a lot of those ideas into hardware.
Microsoft's Majorana 1 processor has the potential to revolutionize various fields, including chemistry, biochemistry, and material science. With its ability to perform complex calculations, Majorana 1 could lead to breakthroughs in areas such as developing new materials and technologies that can efficiently harness and store energy, discovering new medicines and treatments by simulating complex biological systems, and even creating new materials and manufacturing processes that are more efficient and sustainable. Microsoft plans to scale up to 1 million qubits, which could lead to innovations in various fields, and also collaborate with quantum and atom computing to advance its quantum computing capabilities. While there is still much work to be done, Microsoft's Majorana 1 processor represents a significant breakthrough in the field of quantum computing. Its potential to unlock new discoveries and innovations makes it an exciting development in the world of technology. Hannah Hedger for Digivision Network. See you in the next video.
Tech innovation and lifestyle. Please like, share and subscribe to this channel. www.youtube.com/Digivision Network.